So as discussed in today's live session, in this lecture, I will be reviewing the most important points from last lecture, and we're gonna solve two extra problems where these points will get clearer. So let's visit again our mass grid system. So we have a mass attached to a spring, and the mass is oscillating between two values, minus A and plus A. So we agreed that this A is the amplitude of oscillation. And it takes 1 t, so this is period. It's the time for one complete oscillation. So if it starts, for example, at this position X, it's the time it takes to go to A, back to X, to 0, to minus A, to 0, to X. Okay, so this is one period. Okay, what happens at plus A and minus A? It stops. The object stops. Object stops at plus A and minus A. Okay. So if it stops, it means the velocity at plus and minus A is 0. So let's look here at our table. At the equilibrium position at 0, the velocity is maximum. It's positive if it's moving to the right. It's negative if it's moving to the left. At 0, at x equal to 0, the tension force equal to 0. Why? Because F is equal minus kx. And A equal to 0. Why? Because A is F over M. This is Newton's second law, F equal ma, if you remember. Okay. Or if you can remember that A is equal minus k over mx. So it is variable with x. Now, if we are at the maximum position, so if x equal x maximum, then the force is maximum and the A is maximum. A maximum. We just have to pay attention that if it is at a plus A, so x is positive, it's at plus A, the force is backward, so it is negative. And A maximum is also negative. So, sorry, the A will be minus A maximum. At minus A, so over here, A is minus A maximum. And over here, A is plus A maximum. So this is at quick revision. Now, if you go back to lecture 1, we arrived at this differential equation, x double prime equal minus omega squared x. We came to this equation also from Newton's second law. So we started by Newton's second law, F equal minus ma. What is F? It is minus kx. It is equal to, F equal ma. So minus kx is equal to m. And acceleration is the second derivative of x. So it is mx double prime. Okay. So we get the formula x double prime equal minus k over mx. Now, this is a second order differential equation whose solution is either x of t equal a cosine omega t plus phi, or x of t equal a sine omega t plus phi. Okay, we can just always use the first one unless we find it more convenient to use the second one. Now, if we take the first derivative, so the v, it is dx by dt. This is equal to whatever next to the omega jumps outside. So we have minus a omega, the derivative, a omega. The derivative of the cosine is sine, so minus sine. So it is minus a omega sine omega t plus phi. Everything outside sine is V maximum. So this is minus V maximum sine omega t plus phi. So here we use the same thinking as here, whatever outside the cosine function here is oscillating between a plus A and minus A. X is oscillating between a plus A and minus A. here the velocity is oscillating between V maximum and minus V maximum. So V maximum in this case is A omega. Okay, so A omega is V maximum. And this is what we said in one of the lectures. We will prove it later. Now, if we come to A of t, this is d2x by dt squared or dv by dt. So we do derivative for this formula. So we get minus A omega squared cosine omega t plus phi. A cosine omega t plus phi is x. So this is minus omega squared x. And here we are proving again this equation. Anyway, whatever is here outside the cosine function is A maximum. So A maximum is omega A omega squared. Just keep in mind that omega is square root A over M. Okay. Okay. Let's do one exercise. Let's start with this exercise. So a 0.5 object, so we have the mass. This is the mass, is attached to a spring with a force constant 8 Newton per meter. So from the unit, we know that this is K. Vibrates in simple harmonic motion with an amplitude A equal 10 centimeter. Okay, so this is A equal, we can directly make it in meter to make our life easier. I have M, I have K. What can I get? I can get omega is equal to square root K over M. This is square root 8 over 0.5. And the answer to this is 4 radian per second. Not to forget the unit. Okay, so this is what I have in the given. It didn't specify to me at x is at t0 what is happening. So we will assume that at t equal 0, x is equal to 0. But there is no information whatsoever about the velocity. So we will not assume anything about the velocity. We will just assume that at t equals 0, x equals 0. Calculate the maximum value of its speed and acceleration. So now we will start. So in the maximum acceleration, so this is part A maximum is equal omega square times A. So this is equal to 4 times 0.1, and this is equal 0.4 meter. Sorry, this is B maximum. This is 0.4 meter per second. A maximum is omega squared omega times A. A maximum is omega squared times A. This is equal 16 times 0.1. This is equal 1.6 meter per second. Okay. Part B. The speed and the acceleration when the object is 6 centimeters from the equilibrium position. So we have x equals 6 centimeters or 0.06 meter. Find V, find A. Okay, here we have to remember that x of t, we have to put a formula x of t. If we can find the time where x equals 0.06, then I can plug it in the formula for V and the formula for A and get V and A. So we will start with x of t equal. We will start with this and see if this is more convenient for us or the other one. So A cosine omega t plus phi. Okay. And A, we know it is 0.1, no problem with that. Omega, we know it's 4. So here we know A. We know omega. We need to find phi. Let's start with our assumption here. So at t equals 0, x of 0 is equal A, which is 0.1, cosine omega, which is 4, times 0, so that's 0 plus 5. And this is equal to 0. Okay, so we have 0.1 cosine phi equal to 0, which means cosine phi is equal to 0. So how much is phi in this case? What is the angle whose cosine is 0? We get that phi, so implies phi equal plus or minus pi over 2. Okay. Here the problem is that to know if it is a plus pi over 2 or minus pi over 2, we need more information about the velocity at time equal to 0. Because remember, we get the phi from the initial conditions, v and x, but we don't have information about v. So we, assuming that x equal a cosine omega t plus phi doesn't help, because we are stuck by choosing plus or minus pi over 2. So let's take them, instead of x of t equal a cosine omega t plus phi, let's start with a sine omega t plus phi and see if it solves my problem. Okay, so let's take x of t equal. So this is one of the rare problems where the initial conditions are not clear, and that's why we had to do assumption. So x of t is 0.1 sine omega t plus phi. Okay, x of 0 equal 0.1 sine phi. This is equal to 0, implies sine phi equal to 0. What is sine phi equal to 0? This happens for the first time at phi equal to 0. Okay, so notice now I am not any more confused whether I'm no more confused whether I have to choose plus pi over 2 or minus pi over 2. I have one straight answer, phi equals 0. So x of t is equal to 0.1 sine omega times t. Okay, this is now the equation we will follow. X of t is 0.1 omega t. If this is x of t, then what is v of t? V of t is equal, of course, here omega we can plug its value. So what is v of t? Let's plug here the value immediately. Okay, so here implies, so let's erase the box. Okay, so implies x of t is equal 0.1 sine omega, we just put it for t. So this is our equation that we will use. Okay. If x of t is 0.1 for t, then v of t, we just have to take the derivative of the sine function. So the derivative of the sine function is a cosine function, and the derivative of 40 is 4. So I have to multiply this by 4, and then I get v of t is 0.4 cosine 40. Okay, this is another equation. And then a of t, I have to take the derivative one more time. This will give me 4 will jump outside, 16, the derivative of cosine is minus sine. So I get minus 16 sine 40. Okay, sorry, 0.4 times 4 is 1.6 sine 4 of t. Okay, now we have these three equations, so let's call them equation 1. this is equation 2, and this is equation 3. And now, what do we have? We have x equal 6 centimeter or 0.06 meter. Okay, so we plug this in equation 1. So we have 0.06 equal 0.1 sine 4t. We divide by 0.1, so 0.6 is equal sine 4t. Then 4t is equal shift sine. On the calculator, you press shift, then sine 0.6, and we get 4t equal 0.643, and t is equal 0.643 divided by 4, and this gives me 0.16 seconds. Okay, so when I find t, plug in equation 2 implies v at 0.16, or v is equal to 0.4 cosine 4t. This gives me 0.32 meter per second. And the plug t in equation 3, I get, sorry, this is v is equal to, here I get a is equal to minus 1.6 sine 4t. Instead of t, we will put 0.16, and this gives me 0.96 meter per second. Okay. Now, the time interval, we need to find part C, the time interval required for the object to move from x equal to 0 to x equal 8 centimeter. I'm gonna erase this part over here. So the same thing, we assumed from the beginning that at time equal to 0, x is equal to 0. Now we need to find what is the time when x is equal 8 centimeter, or this is equal 0.08 meter. Okay, so we have to plug x equals 0.08 in equation 1. So 0.08 is equal 0.1 sine 4t. 0.8 we divide by 0.1. 0.8 is equal to sine 4t, or 4t is equal shift sine. So on the calculator, you press shift, then sine of 0.8, and we get 4t is equal to 0.93. Okay, t is equal 0.93 divided by 4, and this gives me 0.232. Okay, so delta t is how much? So how much time does it take to go from t0 to 0.232? It takes 0.232 seconds. Okay, let's continue. Another exercise. Okay. Here's the solution. Another exercise. So a simple harmonic oscillator consists of a block of mass m, 2 kilogram, attached to a spring of spring constant K equal 100 Newton per meter. So I have the m and I have the K. Okay, and that's it. And now I have that at time equal 1 seconds, the position and velocity of the block are x1 and v1. So these are the initial conditions. Initial conditions from where I can get A and phi. So always remember, I can, if A is not given, I can get it from the initial conditions. Okay, I have K and M, so I can get omega over here. Omega is square root K over M. If I put instead of K 100, instead of M 2, so it will be 100 over 2, so 50. Square root of 50 is 7.07 radian per second. Okay, let's start. Find the amplitude of the oscillation. So we agreed that to find the amplitude, we have to use the initial conditions. So what are the initial conditions? So we have T1. So A is equal how much? So first we have to assume a function, x of t. We will take the regular one. This is A cosine omega t plus phi. Okay, I know that at x at time is 1 second is equal to A cosine omega. Okay, instead of omega, we can directly put 7.07 from now on. So this is 7.07 times 1. So this is 7.07 plus phi. Okay, and this is given to be 0.129. So this is the first equation. We can work a little bit more on this equation. We can work a little bit more on this equation and get that cosine 7.07 plus phi is equal to 0.129 divided by amplitude. Okay, so now this is the equation I have. V of t, so if I have, this is the first initial condition, then I have initial condition on the velocity. So first we have to find the equation of the velocity. So the equation of the velocity is minus 7.07 times A sine 7.07 t plus phi, okay, implies, now we plug V of 1. This is equal minus 7.07 times A sine sine 7.07 times, instead of t is 1, so 7.07 plus 5. Okay, so what do I get from here? And this is equal to, it's given 3.145. What does this give me? This gives me sine 7.07 plus phi is equal to 3.145 divided by minus 3.145 divided by 7.07 times. Okay, now so these are the two equations I have here. This equation and this equation, these are the two equations I got from the initial condition. This is equation 1, this is equation 2. Now, cosine function equal this much, sine function equal this much. Do you all remember this equation? Using cosine square theta plus sine square theta is equal to 1. Do you remember this formula? Cosine square angle plus sine square angle is equal to 1, implies cosine square 7.07 plus phi plus sine square 7.07 plus phi is equal to, so the first one is square, so this is equal to 0.129 over a square plus minus 3.145 divided by 7.07a square. This is equal to 1. Okay, so I just plug numbers here. So implies 0.129 square is 0.01661 divided by a square plus, from the other side, 3.145 over 7.07 square gives me 0.2 divided by a square is equal to 1. Cross multiply, I take a squared to the other side. So I have 0.016641 plus 0.22. So this is 0.215. I get a squared is equal to 0.215, or a, I just take the radical, square root 0.46. In fact, this is not exactly 0.2, this is 0.198. So when we add them up, it gives approximately this one. Okay, so this is the amplitude of oscillation. Okay. Now, what are the position and the velocity of the block at t0 equals 0? So I need to delete all this and just keep the value of a. So we got from part A, the amplitude is 0.463. Okay. So now, what do we have x of t? What do we know about it? It is 0.463 cosine omega 7.07 t plus phi. So what is the okay, and v of t is equal to 0.463 times 7.07, which is equal to 3.27 sine minus derivative of the cosine is sine 7.07 t plus 1. Okay, these are now the solution. This is how my equations look like. Now we need to find phi. So what is happening at t equal to 0? X of 0 is equal 0.463 cosine phi. Okay. And v of 0 is equal to 0.463 is equal to, sorry, minus 3.27 sine 7.07 phi. So we have to find phi. How to find phi? Remember, we find phi from the initial conditions. We find phi from the initial conditions. Okay, so let me here go to the solution because it's not easy to. So we need to find phi first. We have to remember that we have these two equations. These are the two equations from the initial condition. Cosine 7.075 plus phi is equal to 0.129 over A. And sine 7.07 plus phi is equal minus 3.145 over 7.07A. Now we know A is 0.463. So we plug it in these two equations and I have two new equations. Okay, so I have 0.463 cosine 7.07 plus phi is equal to 0.129, or I solve, I divide by 0.463 here. So I get cosine 7.07 plus phi is equal to 0.28. Notice that the cosine is positive. Okay, if I continue to solve this, if I use my calculator, the cosine is positive. Look here, I hope you remember this from your calculus classes. So the cosine function is on the x-axis, the sine function is on the y-axis. X equals 0 is here, x equal pi over 2 or 1.57 is up here, x equal pi is here at 3.14, and minus pi over 2 minus 1.57 is over here. Okay, when is the cosine function positive? It is positive in region 1 and 4, right? So the 7.07 plus phi must belong to the region 1 or 4. Okay, this we found from the first equation. Now, from the second equation, we have that V1 is negative. Let's go up and look at the second equation. So equation 2, the sign of the angle should be negative, right? So the V1 is negative, So the sign of the angle is negative. If the sign of the angle is negative, then which region should be? We look here. Cosine is positive in region 1 and 4. Sine is negative in region 4. So now we know that the angle is in region 4. Okay, so let me repeat this quickly. So equation 1 says that 0.463 cosine 7.07 plus phi is equal to 0.129. So cosine 7.07 plus phi is equal to 0.129 divided by 0.463. And this is equal to 0.28. Now we use our shift cosine. And we get that 7.07 plus phi is equal shift cosine 0.28. And we get it is 1.28 radian. But we have to remember that it is not the only answer. It can be plus 1.28 or minus 1.28. We have to remember that cosine alpha is equal to cosine minus alpha. So here we use the fact that cosine an angle, let's call the angle theta, is equal to cosine minus theta. Okay, so if I have the cosine of an angle, so here theta is 7.07 plus phi, right? So I have cosine of 7.07 plus phi is equal to 0.28, implies 7.07 plus phi, or theta in this case, 7.07 plus phi or theta, it's equal to cosine inverse, which is shift cosine shift cosine 0.28. The calculator will give me one value. The calculator will give me one value, which is 1.28. But I have to remember that it can also be minus of that value. So this is a plus or minus 1.28. Okay, because cosine theta is equal cosine minus theta. So shift cosine 0.28 can be plus 1.28 or minus 1.28. Now to decide which one of them, I look here and I see that the cosine is positive. If the cosine is positive, then we are either in this region or in this region. So the angle 7.07 plus phi is either in quadrant 1 or quadrant 4. But from the second initial condition, which has to do with V, we know, so let's go back and look at the second initial condition, V, which is, we have the sign is negative. So the sign of the angle is negative. So where is the sign negative? The sign is negative is in region 4. So now we can say that the angle is not plus 1.28, it is minus 1.28 because that angle is in region 4. Okay, so 7.07 plus phi is minus 1.28, phi equal minus 8.35 radian. Okay, now we found phi, right? We found phi. We want x0, so we just plug it in the equation x of t equal a cosine omega t plus phi. So this is equal 0.4463 cosine. I just plug it in the equation, and V0 is equal minus 7.07 times 0.463 sine phi, and I get the values for x0 and V0. Okay. The last part. How much time does it take the block to reach the equilibrium position x equals 0 for the first time? Here, I have to put some information data. What do I have for now? So this is x. Here. X is varying between x equal minus a and x equal plus a. And the equilibrium is somewhere in the middle. What we also have the initial condition. So we have at T1, we have at T0 where x was, so it was somewhere here. Okay, and we have just, we have T1 that we are somewhere here. Let's say we are somewhere here at T1, and we calculated that at T0 it was somewhere here. So let's put numbers now. Let's put numbers. So this is x equal a equal minus 0.463. Okay. We have x equals 0. We have x equal a equal 0.463. Over here, sorry, x equal minus a. Okay, what else do we have? We have that x is equal to 0.13 at t is equal to 1, right? And this is the initial condition. And we have just calculated that at t equals 0, x is equal minus 0.22. This is at t is equal to 0. Now, how much time does it take the block to reach the equilibrium position x equals 0 for the first time? Remember, So let's analyze the question before we solve it. So part C. Remember now that we have x is equal, we have the full equation. X is equal 0.463 cosine 7.07t minus 8.35. Okay. Remember here, all your calculators should be in radian in order to get the proper answer. So this is my x of t. So the question is, how much time does it take the block to reach the equilibrium position x of 0 for the first time? So we want the time it takes to go from here to here, because at t0 it was here, and we want it to reach here. Okay, so one thing here you have to pay attention to, that t should be between 0 and 1. If it is less than 0, this is not the first time, and if it is higher than 1, then it is also not for the first time. In order to find when will it reach the equilibrium position for the first time, the t should be between 0 and 1. So let's solve for the equation. So I have x of t is equal 0.463 cosine blah blah blah. So cosine 7.07. So we need to find t when x is equal to 0. Okay, so we can just put here 0 is equal to 0.463 cosine 7.07 t minus 8.35. Okay, so 0 is equal cosine 7.07 minus 8.45. What is the angle whose cosine is 0? So cosine, so the angle 7.07 t. Here is t. So 7.07 t minus 8.45 is plus or minus pi over 2, because the angle whose cosine is 0 is a plus or minus pi over 2. Let's see which one of them will give me the right answer. If plus pi over 2 implies 7.07 t is equal to pi, which is 3.14 over 2, which is 1.57, plus 8.45. Okay. Okay. Or 7.07 t is equal 10.02 implies t is equal 1.4. So this is higher than 1, so rejected. However, if we take t minus pi over 2 implies 7.07 t equal 1.57. Just a second. 7, yeah. Okay, so this will be minus 1.57 plus 8.45 implies 7.07 t is equal to 6.88 implies t is equal 0.96 seconds. Okay, so with this, we reach the end of today's lecture, and we continue next week.